Hello everyone, this is Force Cyclone here back with another video. It is 12:02 p.m. Eastern Time, June 6, 2023. We're just 6 days into this Atlantic hurricane season, and so far it's been quiet. We just had one named system, Arlene, Tropical Storm Arlene, with winds peaked at around 40 miles per hour, and that's long and gone. And we're looking forward to the next system, which will be named Brett. I don't know when it will be, but we do have one tropical disturbance in the Atlantic Ocean, and that is not expected to develop. They only have a 20% chance of developing, so more than likely that's not going to develop as it moves into those cooler bodies of water in the Northern Atlantic Ocean near Canada and in today's video, we're just going to talk about what is a hurricane and how they form. And if you want to see more videos like this, tracking the tropics, with me tracking the tropics, please subscribe to my channel. This is Force Cyclone here. I'll be giving you guys the full updates on the tropics and Atlantic hurricane season, Pacific, Eastern Pacific, Gulf of Mexico, even in the Caribbean, and all those oceans. I'll be giving you guys the full updates from the National Hurricane Center. So please subscribe to my channel and let's get into the video. So the big question is, what is a hurricane? Now, hurricanes, they're just wind and rainstorms that develop over the ocean. The ocean got to be at least 79, 80 degrees high or higher for them to develop. They need warm ocean water so they could pick up that moisture from the ocean and just build up clouds in very, very high in the sky and, you know, strong thunderstorms within those clouds. And basically just develop off they just move off the coast of Africa, western coast of Africa, as little tropical disturbances. They are just very disorganized thunderstorms, and as they move over those waters, they start to develop and get better organized. Now, the key ingredients for these hurricanes to develop, they need low upper level winds, so the winds are very, very strong. They can rip the storm apart. That is called wind shear. So wind shear is very, very strong in the atmosphere. Most tropical cyclones won't even be able to develop due to the strong winds. They need low level up over winds, and they need moist air. So if the air is very, very dry, like let's say if there's dust in the air, the storms won't be able to develop like that. They need moist air so they could feed off that and get stronger and stronger. And main thing they need is very, very warm ocean temps. That's why hurricanes they develop within you know July and October, because the waters are very, very, very warm due to that sunshine. So as the waters, you know, very, very warm, tropical developments and disturbances can start to get better organized and get more compact, and they will start to get organized, and they will just start to move over the ocean. And then as they move into cooler waters, they can start to dissipate and get very disorganized. So because warm water is the main ingredient for a hurricane to develop, and as you can see right over here, how tropical storms are formed. Water evaporates from the ocean system and come in contact with mass of cold air, forming clouds. So the winds and as the water evaporates, they got to be at least 26 degrees Celsius or higher. They just start to build up, stacks of cumulonimbus clouds and higher in the atmosphere, and they would start to get to more of them and more of them and more of them. And then as they cumulonimbus clouds uh develop, a column of low pressure develops at the center when it's formed around it. So the low pressure system around the center, that can lead to an eye of a storm. That's why you hear about an eye of a storm, eye of a hurricane. As you can see, that's just an area of low pressure where the winds are the calmest. It's very, very calm in the eye of the storm. Out of the whole storm, the eye of the storm is very, very calm. That's when sinking air comes in, and that causes the um clouds to not even form in the center of the storm. That's why sometimes you don't see any clouds or very, very heavy rain in the eye of a hurricane, as you can see right over here. And then as the pressure of the center weakens, the speed of the winds around it increases. So as the pressure of a storm hurricane increases, let's say it went from 1001 to 981. So as it decreases, that means the storm is just getting stronger and stronger and stronger. So yeah, and then it will look like circular counterclockwise right over here. As this system looks right over here, the hurricane will start looking counterclockwise. Counterclockwise hurricanes usually develop in the northern hemisphere due to that, you know, winds from the equator. If they will start to push around a storm, and it'll start to spin counterclockwise. Now that's different in the southern hemisphere. The southern hemisphere, it just spins clockwise due to that the winds in the southern hemisphere, they move at a different direction than the northern hemisphere. So I'll be showing you guys that. So that's just a hurricane, how it develops. It's basically just very, very this more organized shower and thunderstorms, just spinning in circles, rotating, and they could be very, very strong with winds at around 74 miles per hour or higher. That's when it's very classified as a hurricane. So as you can see, hurricanes, they call it hurricanes where we are right over here in the northern North America. We whatever we get, it will be called hurricanes, but it is called different areas. It is called different names in different areas, but they all mean the same thing. You see right over here near Asia, and right over here they're called typhoons. And right over here, down over here near Australia, Madagascar, they're called cyclones, just south of Africa, right over here. But what we're worried about is just the hurricanes that impact us. They could be very, very strong with strong winds and high storm surge. So this is a path of where hurricanes come. So they would develop maybe like in the middle of the Atlantic hurricane season. They will start to develop off the western coast of Africa, and as they move over those warm bodies of water, they will start to move, go through the islands, and start to make that turn due to those cold fronts and high pressures. So there's usually a high pressure called the Bermuda High just in the middle of the Atlantic hurricane season that can steer hurricanes. Also in the Eastern Pacific, hurricanes they don't really last as long due to cooler waters. But this year, that El Nino is going to kick in. It's going to be warmer waters right over here near the equator of South America, Western South America, and very, very strong winds, wind shear. As I said, in the upper level, low upper level winds, but strong wind shear is going to be in the Atlantic Basin. That's going to cause hurricanes to not even develop within this year. But those warm waters, the waters are above average right around now, and they're going to be staying above average during the rest of the hurricane season. So as the water, heats up and get extremely hot, we're going to be experiencing some hurricanes, even though the wind shear is going to kick in and take a toll this year in Atlantic hurricane season. During our Atlantic hurricane season, but the East Pacific hurricane season, it's expected above average due to that El Nino, very, very warm waters right over here near the equator of the Eastern Pacific right over here. So yeah, that's just where hurricanes would develop with near where we are. So as we can see, this is the life of a hurricane. As I said, they start off as little tropical waves, and then they move to a tropical disturbance right over here. Then a tropical depression. Tropical depression is a little stronger than a tropical disturbance. Tropical depressions could be at least 38 miles per hour or lower. That's classified as a tropical depression, and very, very organized. They got to be very organized. As you can see, a tropical storm right over here, you got to be 39 miles per hour or to 73 miles per hour. Tropical storm can be very, very catastrophic, even though the winds aren't very that strong. And as you can see, days go on, it become a tropical cyclone. If the environment is favorable, low level upper winds, moist air, and very, very warm ocean temps, it can become a tropical cyclone. And what we call it is a hurricane within the next couple of days. And let's say Tropical Storm Bertha. They named it Bertha, and it's a tropical storm. As it becomes a hurricane, it'll be Hurricane Bertha, so the names don't switch at all. It would stay the same. And they name hurricanes so they could be easier to track, so they won't get confused. That's the reason why they name hurricanes. Some hurricanes are retired. If they're very, very strong hurricane that did a lot of devastating damage, they retire them. But if they're like, weak hurricanes, then weak tropical storms, then they'll use those name again in the next 6 or 7 years or so. So as a tropical cyclone or hurricane develops, you can see it's right off the eastern coast of United States. They usually go up the Florida Peninsula and up the eastern coast, bringing heavy rainfall and strong winds. And as they move over land, they usually don't really, you know, stay organized, they get to start to dissipate because they need warm water. It doesn't matter if the upper winds are very, very low and the air is very, very moist. They need warm water. And I was saying that's the key factor of a tropical cyclone to develop. And as they move right up the eastern coast of the United States and to the subtropical regions, they start to deal with some fronts that will start to make this storm look like a subtropical storm. As you can see right over here, it looks very, very disorganized from what a tropical cyclone would look like right over here. They could start to get in some stationary fronts and then start to look very, very organized within the next couple of days, and then eventually to start to dissipate due to those cooler bodies of water situated right over here near Canada and Europe, right over here. That's where the waters are very, very cold. No matter what time of the year it is, maybe in August, September, maybe the waters are a little bit warm, but they usually don't really develop right over here or again, or they don't really stay as strong again. We had Hurricane Fiona a couple years back that went right up here through Nova Scotia, right over here. That stayed very, very strong until it went through Nova Scotia, bringing heavy storm surge, strong storm surge, and very, very strong winds. So Fiona really, was a very fish storm. It did affect Bermuda a little bit, but as it moved up the coast, up not up the coast, but through the Atlantic Basin, went up to Nova Scotia. That was a very interesting storm to me, and how it survived that long over those subtropical regions and how it maintained major hurricane strength. So this is just a life of a hurricane right over here. It's tropical depression and tropical disturbance right over here. And then tropical waves and tropical disturbances are kind of the same thing, and they're very just weak, disorganized. You can see it's not really organized in what a tropical storm or hurricane will look like. Very organized with the rain bands right near the eye wall right over here. Now let's talk about the structure of a hurricane. Now a hurricane, the eye is very the calmest part of the hurricane. That's where the air sinks in and keeps any clouds or development within the center to develop. And also the air rises within the eye. That's why the eye right over here that you see right here that doesn't really you're gonna see any clouds or formation within the eye. Is very, very clear, as you can see. It is very rare to get an eye over like let's say Florida's going through a hurricane. The eye went Hurricane Ian, the eye went right through the western coast of Florida. Some people got to see the eye. It wasn't very, very clear as of Hurricane Dorian's eye that impacted the Bahamas. So the eye, that's very calmest part of a hurricane or tropical cyclone. And then we got the eye wall. That's the very strongest part of a hurricane where winds could peak, 100 miles per hour right over there in the eye wall. The eye wall is very, very dangerous and very, very catastrophic. And if we see we have those spiraling rain bands, that's where you can see experience tropical storm force winds within a hurricane right over here. Rain bands, very, very rainy right over here. Not really, hurricane force winds yet until we reach the eye wall. So that's just the formation of a tropical cyclone or hurricane, I should say. You can see the counterclockwise spin right over here due to those winds, spiraling winds up near the equator and cause these spiraling kind of clockwise spin. That's why hurricanes spin due to those trade winds, and not really trade winds, but like winds. It's called a Coriolis effect. At give those spins in counterclockwise in the northern hemisphere and just clockwise in the southern hemisphere due to the Coriolis effect. And that's just the formation of a hurricane right over here. You can see a hurricane can last very long, up to at least 20 days, as you can see right over here, at least 2 weeks or even more. So a hurricane could be very deadly, but they can last very, very long. So as you can see, this is the wind scale of the hurricane. Category 1 hurricane, 74 to 95 miles per hour. Very, very minimal damage if it does affect land, but it can be very, very strong with storm surge up to 4 to 5 feet. So very, very strong. Very, very high storm surge too. So Category 2 hurricane is a little bit stronger than the Category 1, 96 miles per hour through 110 miles per hour. Could do moderate damage and storm surge up to 6 to 8 feet. So very, very moderate right over here. Damage could, snap trees a little bit, branches off, and destroy roofs. And as you can see, Category 3 right over here, 111 miles per hour through 130 miles per hour. It could do extensive damage as it makes landfall with storm surge up to 9 to 12 feet. Category 3 and Category 4 and Category 5 are major hurricanes that they classify with 111 miles per hour up as it classified as a major hurricane. So these are if you see these coming to your area, you might want to be prepared because these are not the hurricanes you want to play with Category 3 higher. So you can see Category 4, 131 miles per hour through 155 miles per hour, extreme damage. So it could cause a lot of damage. And storm surge up to 13 to 18 feet. So that is very, very high storm surge. I wouldn't even be at the coast at a Category 1 uh, or even at a beach as a Category 1 hurricanes impacting your area right over there. because that storm surge can easily go up as the hurricane moves in. And you can see Category 5, that is the peak of a hurricane with over 155 miles per hour, or or um or higher, which is Category 5 a hurricane. Catastrophic damage, it could do devastating damage, but 19 feet of storm surge or even higher. So Category 5 is very, very rare, but very, very strong. As you can see, the last Category 5 we had was Hurricane Ian just a year ago, bringing strong and devastating winds and rain to the western coast of Florida. And it was very, very strong. That was one of the strongest hurricanes that hit the western coast of Florida in a long time, I believe. And one of the strongest hurricanes that really hit the spot for me was Hurricane Dorian in 2019 that devastated the Bahamas with its Category 5, 185 miles per hour winds with wind gusts at around 220 miles per hour. That was a very strong storm that moved up the eastern coast of the United States. But it was very, very weak as it moved up the eastern coast. A little bit weaker, but very, very strong near the Bahamas with the winds at around 185 miles per hour. As you can see, this is the damage from Hurricane Dorian. I believe they're still recovering off of this storm as new systems started moving in as the years went on. But the storm is very, very, very strong. You can see the damage it did right over here. You can see from an airplane, it did a lot of damage due to that just staying stationary, not moving at all. The hurricane was producing 185 mile per hour winds for at least 4 hours because the storm just wouldn't move. It would just stay stationary over the Bahamas. But I thank you all for watching my video. This is Force Cyclone here, and I wish you guys would just subscribe to my channel. I hope you guys subscribe to my channel. Turn those post notifications on because I'll be giving you guys good updates at least every day of the National Hurricane Center. And I thank you all for watching my video. This is just a brief talking about what a hurricane is and how they form. And I'll see you all later.